Hello, and welcome back to more calculus problems. So today we're going to be looking at a few more of the calculus problems from the paper 1 questions. So I'm sorry these aren't quite in order, but let's start by taking a look at May 2014 SP1 time zone 1. And so this problem, first of all, it asks you to find the value of the function that's up here. And then it's going to ask you to take that function and turn it into a rotating solid. So let's start with part A. So if I were doing part A, I would set up my function like this. I would say that my integral is going from 1 to 2. And I know that my function is supposed to be f of x squared, and f of x is x squared dx. Okay, so then I would do a little bit more rewriting before I integrated. All right, so I now have my function, and I'm now going to integrate. So I'm going to add 1 to the exponent, divide by the new exponent. And then you've got to grab your calculator and do a little bit of substituting. So first thing I'm going to do is I'm going to substitute the 2 to the 5th power over 5 minus 1 to the 5th power over 5. And I'm going to put all of that into my brain because apparently this would be in the non-calculator section. So you end up with 31 over 5. Okay, so now let's talk about taking something and turning it into a revolving solid. So doing that means that you're doing pi, that makes it spin, 1, 2, f of x squared dx. Now we already know the value of this part right here, we just calculated it. So this will just be 31 pi over 5, and you're all done with that problem. So hopefully that one went really well for you. Okay, so the next one that I pulled and did some work on was November 2014 SP1 time zone 0. So the first thing it asks you to do for this problem is part A. It says find the coordinate of A. Okay, so here's what I know, is that I know that I have this function, because it's given. Thank you, Einstein, for your assistance, making noise. My coworker is a little bit persistent. All right, so I need to solve this function, okay? So I'm going to set it equal to 0 and I'm going to solve it. Now there's a couple of different approaches. It turns out it does factor, but you could always do the quadratic formula that is on your formula sheet. It just takes a little longer. So I'm just going to go ahead and factor it. Once I have my factors, I'm going to set them equal to 0 and solve them. So I have x equals negative 1/3, which clearly this is on the right hand side, so that x equals negative 1/3 must be over there. And I get x equals 3. Okay, so that's going to be the x coordinate for A. Next thing they would like me to do is they want me to integrate my function, because they said find the y-intercept at this particular point. So let's integrate. Now when I'm doing this, I'm just using the power rule. So let's see, that will be 3x cubed over 3, so x cubed. 8x squared over 2, so 4x squared minus 3x plus c. Now they've given me information about the y-intercept, which is going to help me figure out the rest of this problem. So if I want to figure out what c is for this function, I'm going to use the fact that they told me that at 0, 6, I have an actual intercept. All right, so I'm going to replace all my x's with zeros. And just like that, I found that the function that c is 6. So that means that f of x, which is the original function, is going to be equal to 3x squared minus 8x minus 3. Oh, whoops, wrote down the wrong function. Let me write down the right one. X cubed minus 4x squared minus 3x plus 6. Okay, so there's my function. Now the last part's probably your weird part on this one. Your last part on this one's going to be the odd part. So they're asking you about the local minimum, and they're talking about translating it. Okay, so in order for me to do this, I need to figure out what is the y value that goes with this x value. Okay, so I'm going to take this and I'm going to put it into that equation. So I'm going to find out what f of 3 is. Okay, so let's see here, 27 minus 9 times 4, 36, minus 9 plus 6. So let's see here, that would be negative 3. Oh, I'm gonna break down and use a calculator. So negative 12. Okay, so the y value that goes with this is negative 12. So if I want to do part C, it looks a lot harder than it is. It's just going to be m minus 3 and m plus 12. That's your translation at that point. So the point would be m minus 3, m plus 12. I mean, that's really all there is to that one. It just seems so much more complicated than it really is. Okay, so let's see here. I'm going to skip the one on the back. And we're going to move on to this problem 10. Okay, so we have that problem 10 and we're asked to find some different values. Okay, so find all the possible values where the function is decreasing. So that is going to be all of these sections of the graph. So that is going to be 0 is less than or equal to x is less than or equal to d. So anywhere from here over to here is decreasing. I know that because it's below the x-axis. All right, so now let's move on to B. Part I. Okay, so let's see here. Find the values where the graph has a local minimum. Okay, in order for me to do that, oh, hang on. Hey, Katie, come here. My cat is quite insistent that he get a little bit of attention. I'm going to put him out of the room because he is just a huge floof. See, look, big floof feet. All right, Katie, go outside and play with your friends. Okay, so back to what I was doing. All right, so in order to figure this out, we're going to do f prime of x equals 0, okay, because we know that's true because that's where a local minimum occurs. So I know that if I'm looking at my problems here, that all those intercepts are going to be the actual places where the intercept, where all of my possible local minimums are for my actual graph. So I know that where x equals a could be a minimum. I know that where x equals 0 could be a minimum. And I know where x equals d could be a minimum. So it now says justify my solution. Okay, so I think that the minimum is going to be over here. But remember, I can test all three of them. So here is x equals d. And let's talk about the slope of the line on both sides. Okay, so if I'm looking at this graph, the left-hand side is below the line, and the right-hand side is above the line. So if I was drawing that out, it would look like going down, followed by going back up again. So I know that that is a minimum. Now, if you're looking at 0 over here and you try to make the same table with 0, so let me just do that over here. So here's x equals 0. The left-hand side is positive and the right-hand side is negative because it's below the line. So that gives you a graph that looks like a maximum. So what are you supposed to do with the one that's over here? Well, when I tested that one out, it's positive, positive, which means that it's not going to be a maximum or a minimum. It's going to end up being an inflection point. So that one's a max, and that one's an inflection point. Okay, so now we've talked about that part right there. There's my justification for everything. Let's talk about part C. So part C says find the total area enclosed by the graph. Okay, so C. All right, so I'm going to go from a to 0 with my f prime of x. Because if I integrate that, that'll go back to the original function. Minus 0 to d of f of x. Now the reason I'm subtracting that part is because this area is below the curve. So if I want the total area, I'll need to make it positive. All right, so if I integrate this, I end up with f of x going from 0 to a, and I end up with f of x going from 0 to d. Okay, so if I write all of that out, I will have f of 0 minus f of a minus oops, switch those around, let me fix that. Don't want to confuse anyone. F of d minus f of 0. Okay, so simplifying that out, you get f of 0 minus f of a minus f of d plus f of 0. Okay, so let's see what kind of information they gave us. They told us, well, we don't know what f of 0 is, so we're going to figure that out. We have 2 of those, minus 3, and I'm getting that from right up here, minus negative 1. And let's see here, it says that the total area is 15. Okay, so 15. All right, so let's see here, that will be 2f of 0, looks like minus 2 equals 15. So 2f of 0 equals 17. So f of 0, sorry, I'm squeezing it down here on the bottom, is 17 divided by 2. Let me scoot it up so you can see it. So that is that entire problem done right now. Hopefully that one was okay. Let's see, do I have the one on the back done? I don't think that I do yet, so we will come back to that one. Let me just check real quickly, see if I happen to do it. Oh, looks like I did. Okay. All right, so for this problem, you are going to need to use some u substitution. Here's what your function looks like. You're going from 0 to 4, so 0 to 4, and we're going to take the integral of f of x, so x over x squared plus 1 dx. Okay, so when I'm trying to work a problem out like this, I have no quotient rule, so I've got to use u substitution. So u is going to be x squared plus 1. Now, how do I know that I'm supposed to use the denominator and not the numerator? I tried it both ways. It did not work with the other option. So du is going to be equal to, let's see here, 2x dx. Okay, so I don't currently have a 2x dx, so I'm just going to put one right here. There's my 2, and that will go with these two pieces, and that will become du, but I put a 2 up there, so I have to put a 1/2 on the outside. So let's rewrite the whole thing. You got 1/2 integral sign 0 to 4 of 1 over u du. Okay, so looking at your integral sheet for your directions, if you have 1 over u, that's like having u to the -1 power, which would fail the power rule. So that must mean that there's a formula for it, and there is. That makes that natural log of u going from 4 to 0. Now you cannot just put the 4s and 0s in, because remember those are x endpoints, so I better fix that. So it'll be ln of x squared plus 1 going from 4 to 0. And at this point, I'm just going to do a little substitution. So I will have 1/2 ln of 4 squared 16 plus 1, 17, minus 1/2 ln of 1. Okay, so using the powers of logs, that's going to be 1/2 ln of 17 divided by 1. So that is just 1/2 ln of 17. And this is in the non-calculator section, so that's where you'd stop. Okay, so let's take a look at these last two, last two problems for today. This is my first one. So my first one is going to be this nice one right here. Again, not going to be bad. We are going to need to do a little bit of u substitution and a little bit of product rule. So let's start just by rewriting this a little bit. Remember that this is the same thing as ln of x times x to the -1 power. Okay, so part 1 says find the derivative. Okay, so in order to find the derivative, I'm going to say that my first term is ln of x, and my second term is x to the -1 power. Okay, so remember you're taking the derivative here, so first term's derivative is just going to be 1 over x. Second term's derivative is going to be bring the -1 down, and then subtract 1, so it'll be x to the -2, so 1 over x to the 2nd power. Okay, so now I have all my pieces, and I'm going to do product rule on this. So that means that g prime of x is simply going to be ln of x times -1 over x squared plus 1 over x times x to the -1 power. Okay, so putting all that together, you end up with negative ln of x over x squared plus 1 over x squared. Now you could leave your answer this way, but I will tell you that I did see some examples worked out where they went ahead and made this into a single fraction since it had a common denominator, and they did 1 minus ln of x over x squared as your final answer. Okay, so that is the derivative part. Now we're supposed to integrate this. Okay, so integration. So we're doing an integral on this one that would be ln of x over x dx. I don't have a quotient rule, so I'm going to say u equals, let's see here. I did try this both ways. The ln of x works the best. And so du is going to be equal to 1 over x dx. Now you may not see that down here, but that is all here. Remember that you could rewrite this as ln of x times 1 over x dx. And then you can see all the pieces. So this just becomes u du. And so using the power rule, that's going to become u squared over 2 plus c, which becomes ln of x squared over 2 plus c, and it's all done. So hopefully that one went really well for everybody and they're just like, oh, so simple. Okay, and let's go to our last one that we're looking at today. I think I did this one on your last quiz or test, but let's just kind of walk through it just to make sure you're okay with it. Okay, so here's your function. You're supposed to find derivative 1, derivative 2, derivative 3, and then come up with a general form. Okay, so when you're taking the derivative of this, this is chain rule. Now I'm going to work through the first chain with you just so you can see what it looks like. So here's my function. My inside on this function is the exponent. So my inside derivative of -2. My outside on this function is e to the inside power, and the outside derivative is just going to be e to the inside power. Now when you're doing chain rule, you just multiply these two things together. So f prime of x is just going to be -2 e to the -2x. Okay, so if you keep going with that pattern, you'll see that what's happening is every time we're just going to multiply the beginning part by a -2. So now this is 4, e to the -2x. And if you can guess, the third one is going to be -8, e to the -2x. So what's happening every time is that out front, I'm multiplying by -2. So if I want to write a general formula to the n power, because I don't know how many derivatives I'm going to take of f of x, it would simply be -2. Make sure the -2 is in the parentheses so that when you do it to the first power, you get -2. When you square it, you get +4. When you cube it, you get -8. When you take it to the fourth power, you'll get +16. So putting the parentheses and n on the outside causes it to alternate. -2x. All right, so we are gonna stop there. That's kind of enough for today. Keep working problems. I will post more solutions tomorrow. If there's a particular one that you would like to see, just make sure that you tell me what is the year, is it SP1, and what's the time zone, okay? And that way we can work through as many as you need to see worked out and whichever ones you'd like to see worked out. So I hope